Warning: nitrate, chlorate, and perchlorate salts are strong oxidizers and may burn or explode when in contact with combustible materials. Fire safety protocols must be in place. Barium salts are toxic. Wear gloves when handling them and do not inhale smoke during combustion. Hi guys, here is MIH. Rockets have always fascinated me since my childhood, and I attempted making rocket fuel many times over the past years. Back in December, I made around 100 grams worth of potassium nitrate sorbitol fuel and watched some spectacular fireworks. However, igniting rocket fuel on a steel plate doesn't sound attractive to me. Rocket fuel should be placed near a proper rocket, right? And I wanted to produce some more flame colors other than only the bright purple. Finally, I'm running out of potassium nitrate, so I should probably investigate in some alternative rocket fuel recipe. I'll meet all three targets in this video by providing reliable and safe methods to prepare potassium chlorate sorbitol rocket fuel capable of displaying cool flame colors. I made almost 30 rocket fuel samples to see the best performing ones. However, it should be noted that I prepared and ignited all the fuels in a very damp weather, so the combustion may be tamer. If you're going to replicate this in a dry weather, be sure to make small samples and test it frequently before adding the rocket fuel into a plastic tube of proper mechanical strength to prevent explosions. All my rocket fuel samples use sorbitol as a combustion fuel. Sorbitol has a lower melting point than sugars such as sucrose and glucose and does not caramelize, so it is more convenient and safer to use. The sorbitol is weighted in a beaker and placed on a PTC hot plate. My PTC hot plate has a constant surface temperature of around 250 degrees C. Using a PTC hot plate or a temperature control hot plate is extremely important, as hot plate with higher surface temperatures may ignite the fuel. The oxidizer and other additives are mixed and finely powdered with a mortar and pestle. After the sorbitol fully melts, the oxidizer powder is slowly added into the sorbitol, and the mixture is stirred well with a gloss rod. The addition is repeated until all of the oxidizer is added. At any point, if the mixture begins to turn yellow and darken, immediately remove it from the hot plate and stir it rapidly. However, the mixture should be sufficiently heated to remain as a thick liquid, and it should not solidify. This method is safe enough to prepare both nitrate and chlorate-based fuels as discussed below. The liquid rocket fuel is then poured onto a steel plate or a plastic tube and allowed to cool before igniting with a small blowtorch. From my previous experiences on nitrates, I selected strontium nitrate as a fuel to use together with sorbitol, as I thought it would provide me a brilliant red flame. However, I didn't grind the strontium nitrate very well, and when I heated the fuel, it only charred a bit, but did not ignite. I tried again with strontium nitrate of a higher purity, and it also didn't burn. Dried and powdered calcium ammonium nitrate also showed a similar result, showing that the bad performance of these nitrates is not because of moisture or particle size. To see if the problem is with my sorbitol, I mixed up a standard batch with potassium nitrate and it burned perfectly well, showing that alkaline earth nitrates cannot be used as the sole oxidizer. I think this is because of the different reaction products. Carbonates of alkaline metals are stable, but carbonates of alkaline earth metals decompose to oxides and carbon dioxide in an endothermic reaction that likely prevented the mixture from burning properly. These oxides may be the white fluffy materials you can see here. With this in mind, I adjusted the proportions of nitrates and used a combination of potassium nitrate and CaN. This is probably a decent smoke grinding composition, but certainly not a good rocket fuel. I then suddenly had an idea of using chlorates instead of nitrates. I know this sounds like a horribly dangerous thing to use, but it didn't explode, burned perfectly fine, and I even saw the bright orange flame color of calcium. From this point on, I stuck on the same proportion of 35 sorbitol to 55 potassium chlorate by mass, and swapped the remaining 10% for various salts for coloring the flame. Using strontium nitrate gave the flame a very bright and nearly perfect red color, but the lithium carbonate batch didn't burn as well, and produced a bunch of black carbon materials. More importantly, the flame was orange instead of the reddish magenta color of lithium. I then tested some purple recipe with potassium carbonate added as a retardant, since pure chlorate would likely lead to a very fast and vigorous reaction that is unsafe to use in rockets. However, I'm very unsatisfied with the result, as the sample didn't burn continuously and still retained a yellowish flame. Also, it appears that adding carbonate will result in these black soot-like materials, so don't add carbonates as coloring agents. Another sample I made with potassium chlorate of a higher purity seems to have a pure flame color, but the difference isn't obvious. I think I'll still use the old nitrate recipe to produce a purple color. Since lithium carbonate didn't burn well, I switched to lithium bromide, and this time the flame has a proper reddish color. However, I expected the color to be much more vibrant and more purplish, so I guess lithium isn't ideal to be used in these kinds of fuels, and strontium will be a better choice. The quest on blue and green flames are much more convoluted. These colors, especially blue, is known to be difficult to produce in pyrotechnics and requires a specific combination of copper and chloride. My first attempt used potassium perchlorate and copper oxide, but surprisingly no traces of green and blue can be seen. It was said that barium can produce a vivid green, so I tried it, but it only gave yellow, probably as a combination of green and orange. I then tried potassium chlorate and copper oxide, and that worked much better to give a green flame. But the green color only appeared at the end, and the first part of the flame is still orange. I think this is because the green and blue colors are displayed in colder flames, while orange is more pronounced in hotter ones. With this in mind, I swapped copper oxide for basic copper carbonate in hopes to lower the flame temperature, but it didn't work at all. Finally, I tested if a pure chlorate will give a better green flame, and apparently it did. The orange color is less pronounced, and the green part of the flame is longer. Finally, I casted some of the fuels into tubes and test if they can be safely used in rockets without exploding. The tubes I use are made of PVC, with inner diameter 19.5 mm and thickness 2.8 mm, and it can withstand 1.6 megapascals of pressure as specified by the seller. Be sure to select a thick enough tube from a reputable seller to be safe. The calcium tube gave a bright orange flame and a decent amount of smoke. The strontium tube has a visibly more reddish hue, but the difference isn't very obvious on camera. Apparently, chlorate fuels tend to spit out bits of fuel, so be aware of this and put flammable items away from the burning rocket. The barium tube still burned a yellow color instead of green, and I think this is because of the inherent orange color of this fuel combination. Also note that the vapors produced by barium fuels are very toxic, and it shouldn't be allowed to enter indoor spaces. Wear masks and respirators when handling the fuel and pay attention to the wind direction. Since the weather was too rainy for me to prepare the fuels, I have to temporarily stop experimenting with more fuels. I plan to make more rockets at the end of the summer and test some cool recipe. For example, I want to try adding magnesium, aluminum, zinc, iron, and maybe copper powder to the mix and find the very difficult perfect blue formula. Revisiting the project also double-checks safety aspects of the chlorate-based fuel and serves basis for actual rocket launches hopefully in the near future. See you soon!